Hello, today we are going to solve a problem on the motion of a thrown body, and we will start by looking at this picture. Visitors to a fair are riding on a Ferris wheel with a radius of 5 meters, as shown in the figure. The wheel makes one revolution in 32 seconds. First question, what is the average speed of a passenger on the Ferris wheel? And the second question, if a visitor drops a stuffed toy from the top of the wheel, where will it land? The data we see here in the figure shows that the radius of the wheel is known to be 5 meters, and the bottom of the wheel is 1 Sela 75/100ths of a meter above ground level. And what happens to the task itself? The visitors spinning on this wheel have their own velocity, which in this case will be tangentially directed at every point along the trajectory of this movement. And when the visitor is at the very top of the wheel, the toy falls out, and it turns out, relative to the ground, has some speed. Due to this speed, it begins to move to the ground and passes a certain distance, which you and I had to find. Let's draw a picture of it to show it. So the point of ejection of this toy is in the vertical point of this wheel, and the speed with which this toy began to move we will denote by the letter V. Now, as you and I know, the trajectory of the flight path of such a body is a parabola. This is roughly the arc, is the further movement of this toy, and this is the place where it falls. We have to determine how much distance this toy will have traveled during the entire time of its flight. Let's denote this distance as S. How do we solve such problems? Well, first let's fix the conditions in Dano and then proceed to the solutions. So we are looking directly for the value of the given path S. We know the radius of this wheel. We know the height at which the bottom of the wheel is located. And it is also known that this wheel makes a complete rotation in 32 seconds. First, let's determine the speed at which the given passengers on the wheel will move. And this, by the way, we have just one of the questions of this problem. In order to determine this speed, we must realize that the speed of the wheel is constant, given that the motion is uniform, and then we can determine the average speed at which the passengers move by dividing the path they travel, one complete revolution by the time of this complete revolution. This is in fact the formula for uniform motion itself. Then the speed of a given motion will be determined by the ratio of the distance traveled, denoted by the letter L, to the time of this motion. What is the distance traveled by the passengers if the wheel makes one complete rotation? It is known that in this case it is nothing but the length of the circle, the length of the given trajectory, for the time equal to one full revolution. Let's put a value and calculate this velocity. We already have all the values in SI, so we get the velocity in meters per second. And so after calculating that, we've got a velocity of 0.98 meters per second. This is the speed at which this rotation is occurring. Well, now in order to calculate how far this toy will travel horizontally from the reset point, we must remember with you that here this toy participates in two movements simultaneously. This is falling vertically down the vertical axis and moving horizontally at some constant speed. Well, actually, we have already found this speed. Thus, we can write down several equations in order to obtain a system and then solve it. The first equation is vertical free fall with no initial velocity. That is, vertically downwards, this toy has no initial velocity, so the total height of the fall, let's denote it with a capital letter H, is accordingly the sum of two radii, as we see. That is, this full vertical height will consist of two radii and the height at which the lower part of the wheel is located. And according to the equation of equal acceleration, the outcome will be ascertained by the shape of the square in half. Further, when we find the time of fall, we see that in this case let us denote this time t1, not to be confused with the time of rotation of the wheel. It is important to acknowledge that as time progresses, the toy has the opportunity to traverse a horizontal distance denoted as s, with its constant velocity denoted as v. This distance is determined by the simple formula v multiplied by t1. Let's derive t1 from the formula for the altitude of flight. We get this expression, and instead of h we can write that it's equal to the sum of 2r plus h small. And for the range of flight, we already put these two formulas together. We have acquired a formula and now just need to assign the numerical values to proceed. So the speed v we have known in 0.98 hundredths. Here we substitute 2 times r, it will be 10 plus h1 whole 75 hundredths. And divide by the free fall acceleration of 9.81 hundredths of a meter per second squared. All the data we use here is represented in s values, so the path we get at the end is of course in the meters. So after we've done the calculations, we get a value of approximately 1.52 hundredths of a meter, which is the range of this toy. The value is small, it is clear, because the speed of flight was small, so we can check the reality of this answer by comparing the values with each other, that is, the radius of the wheel plus the height at which this wheel is located, and the speed at which this throw was made is about 1 meter per second, so of course the length of this flight will be small. This concludes our task, and we will see you in our next lessons. Goodbye.